Let's see the next question. Two identical balls A and B having velocities of 0.5 meter per second and 0.3 collide elastically in one dimension. So the velocities of B and A after the collision respectively will be what? So we can say for this particular case, so after collision they will exchange their velocities. So right now initially you can say that, so the velocity of your A, so you can say that it is a 0.5 and B is nothing but obviously 0.3. So after you can say collision, since the collision is elastic, A becomes your 0.3. So you can say that, so these are the two bodies, so where I can say that, so let's say this is a U1 and this is nothing but U2, and again after that, so we can say this is a V2, and again you can say that, so let's say this is nothing but V1, so we can say V2 is greater than V1. So then again you can say for this particular case what is going to happen, so velocity will get exchanged. Yeah, so definitely you can say that, so after the collision the velocity get exchanged over here. So the velocity of A will now become 0.3 and that of your B, yeah, and that of your B also becomes, you can say that, so which is 0.5 over there. So we can say obviously their velocity has got exchanged. Now the velocity of your A is 0.3 and that of your B is 0.5. So you can say your option D is correct over here. So let's say the next question. So a block of mass 10 kg moving in the x direction. So let's say this is a block of your mass 10 kg. So that is moving in the x direction. So let's say this is your M moving in x direction with a constant speed. So the velocity is also given. So let's say that is your 10 meter per second is subjected to a retarding force. So F is equals to 0.1 x. So joule per meter during its travel from x is equals to 20 to 30. Find its final kinetic energy. So work done is nothing but change in the kinetic energy. Initial kinetic energy minus final kinetic energy. So what you have to find out over here, final kinetic energy. So we can say, so from this particular case, so work done is nothing but force into displacement. Yeah, so this is your initial kinetic energy, and again you have to find that your final kinetic energy over here. So what is the initial kinetic energy? Half, again that is a 10, again you can say that it is 100, again that is a force into displacement, and which is nothing but your final kinetic energy over here. So this is again you can say that, so this is 2 5s are 10, so this is nothing but the 500. So 500 minus F into ds, so 500 that is a F into ds over here. So this is nothing but your 500 minus force. So the force you have to find 0.1 into x, so that is your 0.1 into x, and again what is that ds? It is along the x-axis. So 500 minus 0.1 x square upon 2. Again you can say that further the x is changing from where to where, so it is from 20 to 30. So this one you can say that, so this is 500 minus 0.05, and again you can say that, so this is your x square, so 20 to 30, so this is nothing but 500 minus 0.05, so this is 900, so 900 minus 400, so this one you can say that 500 minus 0.05, so this is again you can say that your 500 over here. So this is 500 minus 5 into 10 to the power minus 2 into 5 into 10 to the power 2, so 500 minus 25, so which you can say that, so 475 joule. So definitely your option A is correct for this particular case. So where you can say that its final kinetic energy is 475 joule over here. So let's see the next case. The question, how much does the kinetic energy increases if the momentum is increased by 20%? So the momentum is increases by 20%, so that is the original moment plus 20%. So 20 upon 100, so you can say that obviously 1.2 p. So kinetic energy, I know that, so which is nothing but your half mv square. So this is, again I can write it down, multiply by that m square v square upon m, so that is your p square upon 2m. So the kinetic energy is nothing but p square upon 2m. Now the new kinetic energy, if I increases its momentum by 20%, so 1 by 2p whole square upon 2m, so we can say that obviously that is a 1.44, so that is a p square upon 2m. So definitely you can say that then that is an increase in the 44%. So then we can say there is an increase in the kinetic energy by 44% when you increases its momentum, let's say by 20% over